Variance and standard deviation from grouped distribution. How do we get the value of variance and standard deviation from a group distribution? In our previous lesson, we looked at calculating variance and standard deviation from a frequency table. In this case now, we want to learn how to get it from a grouped distribution like this. When we say something is grouped, in this case there is no a particular item for each interval. Rather, an interval is given to us. So we need to get the item in each of these intervals. And we do that by taking the class marks, which is the sum of the lower class limit and the upper class limit divided by 2. So let's do that right away. Example 4, it says the data below is that of the score. The data below is that of the shoe sizes of 100 men for the NYSC. Calculate for the data the variance, the standard deviation. So we need to prepare a table that will reflect all the items that we need. We have the class interval, which is the shoe size. The shoe size within this shoe size, since it is given in range 50 to 54, and the next one is 55 to 59. The next is 60 to 64. The next is 65 to 69. And the next is 70 to 74. And finally, we have 75 to 79. 75 to 79. Here, we need to get the class mark. The class mark that we use as X. The class mark is S. And like I said earlier, class mark is obtained by adding this and this, then divide the result by 2. So 50 plus 54 is 104. 104 divided by 2 is 52. Then 55 plus 59 divided by 2 is 57. 60 plus 64 divided by 2 is 62. Then 65 plus 69 divided by 2 is 67. Looking at this data, you can see that it's growing by 5. So to get the next one, we can add 5 to 67, which will give us 72. The next one will be 77. So that is X. And we need to get the frequency F, which is still there in the table. For the first one, we have 7. For the second one, we have 15. For the third, we have 44. And we have 13. We have 9 and 12. Okay, now that we know the X and the F, remember that before we can calculate the standard deviation and the variance, we need to get the mean deviation. And before we can get mean deviation, we need to get the mean. So the first thing we need to calculate here is mean, which is S bar summation Fs over summation F. Because of that, we need to get Fs as our next column. The Fs, this is our S, this is F. 52 times 7 is 364. 364. And 57 times 15 is 855. 855. 62 times 44 is 2,728. 2,728. Then 67 times 13 is 871. 72 times 9 is 649, 648 rather. And finally, 77 times 12 is 924. 924. To get the mean, we need to sum of fs, sum of f, then divide. So the sum of these, remember this is our fs. When we add up all the number in this row, we get 6,390. 6,390. And when we add the frequency, where is the frequency column? This is frequency column. When we add up all the frequency, we have 100. 100. Therefore, our arithmetic mean S bar will be 6,000. What was the value just now? 390. 6,390 divided by 100, which is 63.9. So our X bar is 63.9. With that, we need to get the deviation. And get deviation now, which is X minus S bar. That is a deviation from the mean. The next thing we need to get is to square this deviation, which the sum of all the square of the deviation will give us the standard deviation. So the next column we need to prepare will be S minus S bar square. We can decide to square it here like I did in my previous example, but for clarity, let's separate it. And X minus S bar square. Then finally, to get the excuse me, get the variance, finally F multiplied by S minus S bar square will give us the next column. So let's do that one after the other. X minus X bar. Our X bar, oh, I clean it. I can write it here. Our S bar is 63.9. And our X here is 52. So 52 minus 63.9 will give us minus 11.9. But since we are taking the absolute value of it, this vertical slash here mean the absolute value. Absolute value of minus 11.9 is 11.9. Now I have 11.9. Then 57 minus 63.9 will be 6.9. 6.9. 62 minus 63.9 is 1.9. That is actually minus 1.9. The absolute value of it is 1.9. Then 67 minus 63.9 is 3.1. 72 minus 63.9 is 8.1. Then finally 77 minus 63.9 is 13.3. 13.1 rather. And the square of each of these, 11.9 square is 141.61. 141.61. 6.9 square is 47.61. Then 1.9 square is 3.61. 3.1 square is 9.61. 8.1 square is 65.61. 65.61. Finally, 13.1 is 171.61. 171.61. And F times X minus X bar square. That is the frequency multiplied by the variation, deviation rather, from the mean is F here is 77 multiplied by 1 41.61 is 991.27. I have 991.27 right there. And here we have 15 multiplied by 47.61 is 714.15. 1.44 rather, 0.3.61 is 158.84. 158.84. Then 13 times 9.61 is 124. 124.93. 9 times 65.61 is 590.49. Finally, 12 multiplied by 171.61 is 2059.32. So we need to sum up all of this. We also need to sum up each other one. The frequency, okay, it's already done, is summation f s minus s bar square over summation f. So that when we sum up all the items in this column, we have 4,939. 4,939. Adding all of this number together, 4939. So that's our variance will be 4939. Let me remove that point. 4939 divided by summation f is 100. I will divide by 100, which is 49.39. Then standard deviation is square root of variance, which will be square root of 49.39. Well, the square root of 49.39 is 7.027. So approximately 7.03.